This figure shows the area changing, which means the flux is changing and current and EMF is induced. In this figure, we only have a metal bar, which is a conductor moving through a magnetic field. Because electrons can move easily in conductors, the electrons follow the right-hand rule and move up to one end of the bar, leaving the top of the bar negative and the bottom positive. This creates a potential difference, meaning voltage. The same effect can happen to airplanes flying because the Earth produces its own magnetic field, and the airplane is one big conductor moving fast through the Earth's magnetic field. We can measure the flow of blood because blood contains ions, positive particles. These ions flow through the magnetic field and are forced upward onto the metal plate because of the right-hand rule. So the top of the plate is positive and the bottom is negative. And a voltmeter measures the potential difference. If we know the potential difference, or EMF, we can calculate the speed by using EMF equals B times L times V. I believe athletes have a faster flow of blood to bring oxygen quicker to their muscles. In this example, we have an airplane traveling 1,000 kilometers per hour in a region where the Earth's magnetic field is about 5 times 10 to the negative 5 Tesla and is nearly vertically. What is the potential difference induced between the wingtips that are 70 meters apart? Now first, before we begin, let's convert 1,000 kilometers per hour to meters per second to get 280 meters per second. Now we can use our EMF equation for a conductor moving through a magnetic field. Plug and chug, and we get roughly around 1 volt, or a potential difference from wingtip to wingtip as 1 volt. In this example, the rate of blood flows in our body vessels can be measured using the apparatus, since blood contains charged ions. Suppose that the blood vessel is about 2 millimeters in diameter, the magnetic field is 0.08 Tesla, and the EMF measured is about 0.1 millivolts. What is the flow velocity of the blood? We'll start with our EMF equation, rearrange it to solve for velocity, plug and chug to get 0.63 meters per second as the blood flow. That seems pretty fast to me. Just note that I changed millivolts to volts, and of course millimeters to meters. A changing magnetic flux induces an electric field. This is generalization of the Faraday's law. The electric field will exist regardless of whether there are any conductors around it. We're not going to go into detail into this. Now, in this figure, we have a rotating loop in a magnetic field. This setup induces current because the flux is changing due to the rotation of the loop. The slip rings are used so that the wires don't get tangled up. Now recall that flux increases current. Note that as the flux increases, current will flow in one direction, and then as flux decreases, the current will switch directions. This is known as alternating current, meaning the current switches directions back and forth. To have a direct current, meaning current flows in one direction, the slip rings have a split down the middle, so that the voltage is always positive, or always flowing in one direction. With only one loop rotating, the voltage will peak and then go down to 0 and repeat itself. However, if you have multiple loops rotating, the voltage doesn't get a chance to reach 0 before another loop induces current. This setup helps create a steadier stream of current and voltage. And this is how generators work. Now, to turn the axle, we could use nature to help us, like water from a dam or like wind from windmills. These are just a couple examples of green energy.